Morning to all of you. In the last lecture, we have seen first type of non-linear partial differential equation, solution of first type of non-linear partial differential equation. In today's lecture, we will see solution of second type of non-linear partial differential equation. So on the screen, you can see that I have written here type 2, and the equation is f of p q z equal to 0. So equation f of p q z equal to 0, it means that an equation containing okay, so equation f of p q z equal to 0. It means that is an equation containing three variables p, q, and z only. So please be sure that three variables should be only p, q, and z. Then only we can solve it by using type 2. We don't have the choice of selecting variables. Means if there are variables pqx or pqy or xyz, then it do not constitute second type. In second type, number of variables should be 3, but particularly variables should be only p, q, and z. P, q, and z should be there only. Okay? So for solving this type of equation, for solving this type of equation, we have to consider capital X, it is equal to small x plus ay. For solving this type of partial differential equation, we are introducing here new variable capital X, it is equal to small x plus ay. And whenever we are going to change any dependent or independent variable, we have to change their derivatives also. Small xy, these are independent variables. Z, it is main dependent variable. P and Q are derivatives. P means del z by del x, Q means del z by del y. So here we are changing independent variable. In place of x plus ay, we are going to use capital X. So it means that we have to change derivatives also. Please remember that whenever you are going to change any variable, either it is dependent or independent, in differential equations, in that case, we have to change their derivatives also. So derivatives means here we have to change values of small p and small q. Here we have to change values of small p and q also. So in this type, after using this substitution, capital X equal to small x plus ay, value of p, it will change to dz by d capital X, and value of q, it will change to a into dz by d capital X. So one thing which you have to remember, for solving partial differential equation of the type f of pqz equal to 0, we have to consider capital X equal to small x plus ay. एक तो ये substitution हो जाएगा, and after changing variable we have to change their derivatives also. So derivatives are p and q. So small p, it will be dz by d capital X, and small q, it will be a into dz by d capital X. Now someone may think that how we are getting these values of p and q. So for that, just I am giving you one hint here. I'm not going to explain it completely due to binding of time. I am just giving one hint to you here. Here we can form a relationship or mapping between the variables, starting from main dependent variable z. So z, it is a function of a small xy, and capital X, it is also a function of a small xy. We have considered capital X, it is equal to small x plus ay. So it means that we can form a mapping that it is a function of capital X, and these are the functions of small x and small y. So from this mapping, we can find two derivatives of z with respect to independent variables. So last independent variables are x and y. So from that, we can find value of del z by del x and we can find value of del z by del y. These two partial derivatives we can calculate here. So del z by del x, it is equal to, it will be first derivative of z with respect to middle variable, which is x. So here we are having single variable capital X, so operator will be used as d, because if we are having more than one independent variables, then only then only we are going to use operator del. If we are having more than one independent variables, then only we are going to use operator del. Otherwise, for single variable we have to use operator d. So पहले z का डेरिवेटिव आएगा with respect to x, तो ये हो जाएगा dz by d capital X into again derivative of this capital X with respect to small x. So now on right hand side we are having more than one variables, we are having two variables here. So यहाँ पे operator change हो जाएगा, ये हो जाएगा del capital X by del small x. Similarly, second derivative del z by del y. तो पहले आएगा डेरिवेटिव ऑफ z विद रिस्पेक्ट टू कैपिटल x, तो सिंगल वेरिएबल है कैपिटल x यहाँ पे, तो इसके लिए ऑपरेटर रहेगा d dz by d कैपिटल x into again derivative of capital X with respect to independent variable y, and here on right side we are having two independent variables x and y. So more than one variable अगर आता है तो ऑपरेटर जो रहेगा it will be del, तो ये हो जाएगा again derivative of capital X with respect to y, del x by del y. So by using rule of transformation of independent variables, we can get these values del z by del x and del z by del y. Now we know that अभी del z by del x जो यहाँ पे लिखा है लेफ्ट हैंड साइड पे, so we know that del z by del x it is nothing but t, ठीक है, and del z by del y it is nothing but q. On right hand side this value del capital X by del small x, so derivative of capital X with respect to small x, partial derivative, it is 1. So remaining term will be only dz by d capital X. This will be the only remaining term. That's why we have written here p it is equal to dz by d capital X. In second equation, we are having del capital X by del y, means partial derivative of capital X with respect to y. So partial derivative of capital X with respect to y, that is nothing but a. So यहाँ पे ये बॉक्स की जगह पे a आ जाएगा, तो it will become a into dz by d capital X. So that's why value of q it is a into dz by d capital X. ठीक है. So by using rule of transformation of independent variables, we have to we can calculate the values of p and q in this manner. So now just come to the topic type number 2, equation containing three variables p, q and z. We are going to solve this type of equation. So for solving this type of equation, we have to remember only two things. First, we have to introduce new variable capital X. तो ये capital X का वैल्यू आपको कंसिडर करना है हर प्रॉब्लम के अंदर, capital X इक्वल टू स्मॉल x प्लस ay. इसके बाद जब भी आप वेरिएबल को चेंज करते हो तो करस्पॉन्डिंग डेरिवेटिव चेंज करना कंपलसरी है. तो अभी ये वैल्यूज आपको डायरेक्टली यूज करना है. p it is equal to a into dz by dx, q it is p equal to dz by dx and q equal to a into dz by dx. ये दोनों वैल्यूज आपको कंपलसरीली यूज करना है. अभी ये आपने डायरेक्ट लिखा तो भी चलेगा. So let's see a problem based on this type. And one more thing, after applying this substitution, given partial differential equation will be converted into ordinary differential equation of first order and first degree. तो मैं यहाँ पे लिख देता हूँ, after applying this substitution, given equation will be converted to ordinary differential equation of first order and first degree. So compulsorily, after applying this substitution, given partial differential equation will be converted to ordinary differential equation of first order and first degree, which we can solve by using method of separation of variables. We can solve by using method of separation of variables, जो कि ऑलरेडी आपको पता है. ठीक है. Now we will take a problem. So first problem, solve q in bracket p square z plus q square equal to 4. So as usual, first of all, we will write given partial differential equation as it is, q in bracket p square z plus q square equal to 4. Mark it as equation number 1. Now we have to identify type of equation. Before solving it, we have to identify type of given partial differential equation. And clearly we can see here, given equation, it contains 3 variables. It contains 3 variables, P, Q, and Z. So therefore, it is of the type, f of P, Q, Z equal to 0. So we have identified the type of given partial differential equation. Given equation, it contains 3 variables, particularly P, Q, and Z. Therefore, it is of the second type, f of P, Q, Z equal to 0. And after identifying the nature of given equation, abhi decide hoga कि it is of the type f of P, Q, Z equal to 0. Therefore, for solving this equation, we have to consider capital X equal to small x plus ay. ये value हमें consider करना है. For solving this equation, we have to consider capital X equal to small x plus y. Now, considering that as we are changing variables, so we have to change derivatives also. So derivatives भी change हो जाएंगे. Small p, it will be replaced by dz by d capital X, and small q, it will be replaced by a into dz by d capital X. Okay. So apply this substitution to equation number 1. Applying this substitution to equation 1. So equation 1, it is q in bracket p square z plus q square equal to 4. Equation 1 जो है, इसे एक बार मैं फिर से यहाँ पे लिख देता हूँ, so that it will be visible to us which things we are changing here. Q in bracket p square z plus q square equal to 4. It is the given equation. अब इसमें हमें substitution को apply करना है. So we have considered capital X equal to small x plus ay. So no need to write this value because we don't have small x plus ay, the term of x plus ay in given equation. So what we will change? We will only change derivatives. So small p की जगह पे dz by d capital X put करना है, और small q की जगह पे a into dz by d capital X पुट करना है. Okay, so change these two values. So it will become q means a into this one. Okay, so q it will be a into dz by d capital X in bracket p square into z. So value of p it is dz by d capital X. So p square will become its bracket square into z as it is plus q square. So value of q it is a into dz by d capital X. So q square will be its bracket square, main bracket complete and equal to 4 it is as it is. Okay, we have substituted values of p and q. Now, after applying this substitution, we have written that after applying this substitution, given differential equation will be converted into ordinary differential equation of first order and first degree, which we have to solve by using variable separable method. अब इसे हमें वेरिएबल सेपरेबल मेथड से सॉल्व करना है. एक तो ये क्लियर हो गया कि ये इक्वेशन जो है यहाँ पे it is converted to ordinary differential equation because the operator is d by dx now. ठीक है, so we have to convert it into variable separable form. It means that we have to separate the terms from derivative. Derivative जो है इसे भी हमें split करना है, means dz by dx. इसमें से dz और dx दोनों को हमें separate करना है. On one side there should be dz and on other side there should be dx. ठीक है, लेफ्ट हैंड साइड पे dx रहना चाहिए, राइट हैंड साइड पे लेफ्ट हैंड साइड पे dz अगर रहा तो राइट हैंड साइड पे dx आना चाहिए. डेरिवेटिव की टर्म्स को सेपरेट करना है. But in this problem we can see that derivative it is present at three different places: dz by dx bracket square a into dz by dx bracket square. Derivative it is present at three different places. So if you want to separate the terms of derivative dz और dx दोनों को अगर separate करना है तो first task जो रहेगा कि we have to combine all the terms of derivatives. There should be a single term of derivative. There should be a single term of derivative, then and then only we can separate the values of dz and dx. So अभी डेरिवेटिव का सिंगल टर्म रहना चाहिए, तो इसे सिंप्लीफाई करना होगा. अभी सिंप्लीफिकेशन क्या कर सकते हैं कि फ्रॉम मेन ब्रैकेट वी कैन टेक dz by dx ब्रैकेट स्क्वायर कॉमन. मेन जो ब्रैकेट है इसे हम ऐसे लिख सकते हैं, वी कैन राइट इट एज a into dz by dx. It is as it is. First term it is z into dz by dx bracket square. Second term a dz by dx whole square means it will become a square into dz by dx whole square, main bracket complete equal to 4 as it is. Now we can take this dz by dx bracket square dz by dx bracket square common. इसे हम कॉमन ले सकते हैं, so it will become a into dz by dx as it is and into this dz by dx bracket square common. So it will become dz by dx bracket square and into this dz by dx it will become dz by dx bracket cube. The remaining things in the bracket it will be z plus a square only equal to 4 it is as it is. Okay. Now we are trying to separate the term of derivative. हमें पहले डेरिवेटिव की टर्म को सेपरेट करना है तो ही हम dz और dx को सेपरेट कर सकते हैं. So डेरिवेटिव की टर्म को लेफ्ट हैंड साइड पे रहने दो. Remaining all terms will transfer on right hand side. Remaining all terms we will transfer on right hand side. So we can write it as a as it is रहेगा into dz by dx bracket cube that is equal to 4 upon z plus a square means dz by dx bracket cube that is equal to 4 upon a into z plus a square. So in this way we have separated the term of derivative on one side and the remaining terms on other side. Now वी वांट टू सेपरेट द टर्म्स ऑफ dz एंड dx। अब ये जो डेरिवेटिव है इसमें से हमें dz और dx ये दोनों डिफरेंशियल कोएफिशिएंट्स को सेपरेट करना है। वी आर ट्राइंग टू कन्वर्ट इट इनटू वेरिएबल सेपरेबल फॉर्म। सो डायरेक्टली वी कैन नॉट सेपरेट dz एंड dx फ्रॉम दिस इक्वेशन बिकॉज ऑफ दिस पावर 3। सो जब तक ये पावर 3 यहाँ से रिमूव नहीं होगा तब तक हम dz और dx को सेपरेट नहीं कर सकते। सो टेकिंग क्यूब रूट ऑफ दिस इक्वेशन, take cube root of this equation so that power 3 will be get removed and then we can separate dz and dx. So after taking cube root of this equation, we can write it as dz by dx it is equal to cube root हमें लेना है cube root means power 1 by 3, so it will become 4 to the power 1 by 3 upon a to the power 1 by 3 and into z plus a square bracket to the power 1 by 3. So now we can separate the terms of derivative. So we'll get dz it is equal to 4 to the power 1 by 3 upon a to the power 1 by 3 into z plus a square bracket to the power 1 by 3 into dx. So in this way we have separated the terms of differential coefficients dz or dx दोनों separate हो गए, but we are trying to convert it into variable separable form, and the condition for getting variable separable form is that with differential coefficient dz there should be terms of dx, there should be terms of z। dz के साथ z की टर्म्स आनी चाहिए और dx के साथ x की टर्म्स आनी चाहिए। dz जो रहेगा तो dz के साथ z की टर्म्स आनी चाहिए और dx के साथ x की टर्म्स आनी चाहिए। कांस्टेंट कहीं पे भी प्रेजेंट रहा तो दैट डजंट मैटर, कांस्टेंट लेफ्ट हैंड साइड पे रहे या फिर राइट हैंड साइड पे रहे दैट डजंट मैटर। So on right hand side we can clearly see that we are having 4 to the power 1 by 3 upon a to the power 1 by 3, it is constant, but the next bracket 1 upon z plus a square bracket to the power 1 by 3, this bracket it contain variable z, तो variable z की terms को dz की तरफ हमें transfer करना है, this bracket to dz, so we'll get it as z plus a square bracket to the power 1 by 3 into dz it is equal to 4 to the power 1 by 3 upon a to the power 1 by 3 into dx as it is, and now this equation it is converted into variable separable form. Now it is converted into variable separable form, and after getting variable separable form we know that for finding its solution we have to integrate this equation. So therefore on integrating our equation we will get z plus a square bracket to the power 1 by 3, that's integration with respect to z, that is equal to on right hand side 4 to the power 1 by 3 it is constant, upon a to the power 1 by 3 it is also constant, so we will keep them outside the integration, remaining term integration of dx. Now take the integration which will give the final required solution. So integration of left hand side z plus a square bracket to the power 1 by 3, its integration, power of variable z it is 1 inside the bracket, so we can directly take its integration. So by using formula of ax plus b bracket to the power n, by using formula of integration of ax plus b bracket to the power n, it is ax plus b bracket to the power n plus 1 upon n plus 1 into coefficient of x. So by using that result we can directly take the integration of z plus a square bracket to the power 1 by 3, it will become z plus a square bracket to the power 1 by 3 plus 1 upon 1 by 3 plus 1 into coefficient of z. So coefficient of z it is 1, so no need to write it. Right hand side 4 by 3 it is as it is upon 4 to the power 1 by 3 as it is, a to the power 1 by 3 as it is, into integration of dx it will be x plus constant of integration c. Now simplify it. Left hand side it will be z plus a square bracket to the power 1 by 3 plus 1, it will be 4 by 3 upon 4 by 3. It is equal to 4 to the power 1 by 3 upon a to the power 1 by 3 into capital X. So capital X, this variable, we have introduced it for solving given partial differential equation. ये ऑलरेडी इक्वेशन के अंदर प्रेजेंट नहीं था. वी हैव इंट्रोड्यूस्ड दिस वेरिएबल. सो लास्ट में भी ये वेरिएबल को हमें रिमूव करना है. सो कैपिटल X, इट मींस दैट व्हाट यू कंसीडर इट एज, you consider it as small x plus ay and plus c, it is as it is. So finally we will get z plus a square bracket to the power 4 by 3, it is equal to 1 upon 4 by 3, transfer it on right hand side, it will become 3 by 4, sorry, not 3 by 4, it will be 4 by 3 itself. 1 upon 4 by 3, इसको अगर राइट हैंड साइड पर ट्रांसफर किया तो इट विल बिकम 4 by 3 as it is into 4 to the power 1 by 3 upon a to the power 1 by 3 into x plus ay and plus constant c. So got the solution. और अगर इसे सिंप्लीफाई करना है तो राइट हैंड साइड पे 4 into 4 to the power 1 by 3 इसे कंबाइन कर सकते हैं. लेफ्ट हैंड साइड as it is z plus a square bracket to the power 1 by 3, it is equal to right hand side 4 into 4 to the power 1 by 3, it will become 4 to the power 4 by 3 upon 3 as it is 3 times a to the power 1 by 3 and into x plus ay plus c. So which is the final required solution of given partial differential equation. That's it. So it means that for solving partial differential equation of the type f of pq is equal to 0, we have to consider capital X equal to small x plus ay, small p और small q के values को change करना है, and after applying this substitution, equation will be converted into ordinary differential equation of first order and first degree, which we can solve directly by using variable separable method. So next problem. Second problem based on same type. You have to solve q square, that is equal to z square p square in bracket 1 minus p square. First of all, we will write given partial differential equation as it is. Q square, it is equal to z square p square in bracket 1 minus p square. Now clearly we can say that this equation contains three variables p, q and z. So it contains three variables p, q and z. Therefore it is of the type f of p, q, z equal to 0. So after identifying the type, अब ये decide होगा कि it is of the second type f of p, q, z equal to 0. Therefore, for solving this equation, we have to consider, for solving it, we have to consider capital X equal to small x plus a. So we are considering here capital X equal to small x plus a. Now, whenever we are going to change the variables, we have to change their derivatives also. So derivatives, small p, it will be dz by d capital X, and small q, it will be a into dz by d capital X. So apply this substitution to given equation. Applying this substitution to given equation 1. Let's check it. What is given equation here? So it is the given equation. Q is equal to z square p square in bracket 1 minus p square. Mark it as equation number 1. So we write same equation and then apply the substitution. So here given equation 1, it is q square, it is equal to z square p square in bracket 1 minus p square. So apply the substitution. Q square, it is nothing but a into dz by d capital X bracket square, z square as it is, p square, it means that dz by d capital X bracket square as it is, and in bracket 1 minus p square means again 1 minus dz by d capital X bracket square. So after applying this substitution, we have to convert it into ordinary differential equation, which we can solve by using method of separation of variables. तो वेरिएबल अगर सेपरेट करना है तो उसके लिए रिक्वायरमेंट है कि डेरिवेटिव शुड बी प्लेस्ड एट ओनली सिंगल प्लेस, बट हियर डेरिवेटिव इट इज प्रेजेंट एट 3 different places. So what we have to do? Either we have to combine the derivative or try to cancel any term. So from left hand side, a dz by dx whole square, we can write it as a square into dz by d capital X bracket square. Right hand side, z square as it is, dz by d capital X whole square, it is as it is, in bracket 1 minus dz by d capital X bracket square, it is also as it is. Now from left hand side and right hand side, from left hand side and right hand side, this dz by dx bracket square, this dz by dx bracket square, it will be get cancelled. Remaining terms will be a square, it is equal to z square in bracket 1 minus dz by dx bracket square. Now derivative is present at only one place, so find the value of derivative and then separate dz and dx. अब यहाँ से डेरिवेटिव का वैल्यू फाइंड करना है और उसके बाद उसे वेरिएबल सेपरेबल के अंदर कन्वर्ट करना है. सो डेरिवेटिव का वैल्यू हमें फाइंड करना है. तो पहले ये z स्क्वायर को लेफ्ट साइड पे लेके आ जाओ. z स्क्वायर को अगर लेफ्ट साइड पे लेके आया तो ये हो जाएगा a स्क्वायर अपॉन z स्क्वायर, that is equal to remaining term 1 minus dz by d capital X whole square. Now we are trying to find value of derivative. So derivative it is negative on right hand side. तो डेरिवेटिव को अगर लेफ्ट साइड में लेकर आया तो ये पॉजिटिव हो जाएगा dz by d capital X whole square, it is equal to 1 as it is, and a square upon z square, इसको राइट साइड पर ट्रांसफर कर दो, it will become 1 minus a square upon z square. So again, if you simplify it, we got the value of dz by dx bracket square, but हमें सिर्फ dz by dx चाहिए, bracket square को भी हमें रिमूव करना है. So before taking square root of this equation, first simplify the right hand side. dz by dx whole square on left hand side as it is, right hand side को अगर क्रॉस मल्टीप्लाई किया तो ये हो जाएगा z square minus a square upon z square. Z square minus a square upon z square. Now take the square root of this equation. After taking square root, it will become dz by d capital X, it is equal to square root of z square minus a square and upon z. and now we can separate the derivatives. अभी हम इसे वेरिएबल सेपरेबल फॉर्म में कन्वर्ट कर सकते हैं. So separate the derivatives. We will get dz, that is equal to square root of z square minus a square upon z into dx. बट dx के साथ तो सिर्फ x की टर्म हमें चाहिए थी, तो ये जो z की टर्म राइट हैंड साइड पे प्रेजेंट है उसे लेफ्ट साइड पे लेकर आ जाओ. इट विल बिकम z अपॉन स्क्वायर रूट ऑफ z स्क्वायर माइनस a स्क्वायर dz, इट इज इक्वल टू रिमेनिंग टर्म जो प्रेजेंट है यहाँ पे on right hand side, it is only dx, and now it is converted to variable separable form. And after getting variable separable form, we know that we have to integrate this equation. So integrate it. On integrating this equation, we get integration of z upon square root of z square minus a square with respect to z, that is equal to integration dx. On left hand side, we can adjust here 2 and 1 by 2. Okay, so we have adjusted here 1 by 2 and 2 on left hand side, and the reason behind is that now the function inside the integration, it is integration of twice z upon square root of z square minus a square. So its integration we can take directly by using standard result. We are having a standard result which I will write here. Integration of f dash of x upon square root of f of x with respect to x, that is equal to 2 times square root of f of x. This is the standard result. Now we are trying to apply this result on left hand side. So we can see that we are having here integration of twice z upon square root of z square minus 1. स्क्वायर रूट के अंदर का जो फंक्शन रहेगा वी आर कंसिडरिंग इट एज एफ ऑफ एक्स. तो स्क्वायर रूट के अंदर यहाँ पे प्रेजेंट है z स्क्वायर माइनस a स्क्वायर, एंड डेरिवेटिव ऑफ z स्क्वायर माइनस a स्क्वायर इट इज ट्वाइस z, जो कि ऑलरेडी न्यूमरेटर में प्रेजेंट है. मींस दिस इंटीग्रेशन इट इज कंप्लीटली इन दिस फॉर्मेट, f dash of x upon square root of f of x. So its integration will be 2 times root of f of x. So therefore we can write it as now 1 by 2 जो इंटीग्रेशन के बाहर था वो एज इट इज रहेगा, and integration of twice z upon square root of z square minus 1, it is 2 times the square root of z square minus a square, which is the function here. Okay. So this bracket, it is the integration of left hand side, and on integration on right hand side, integration dx, it is nothing but capital X plus constant of integration c. Now 1 by 2 and 2 will be get cancelled on left hand side. Remaining term square root of z square minus a square, that is equal to capital X plus c, and capital X, it is nothing but small x plus ay plus c, which is the required solution of given differential equation, which is required solution of given partial differential equation. That's it.